In this video, we're going to study piecewise function. And to do that, we look at this example. This example is the example of piecewise function. F of x is the function name. This is the function pieces. X squared 2 and x plus 2. And this whole thing here is a domain. So right here is a domain of f. So let's say that f of x equal to x squared if x is less than 0. F of x equal to 2 if x equal to 0. F of x equal to x plus 2, x is greater than 0. Now to understand the piecewise function, let's start with part A. We're looking for f of minus 2. They're asking us to evaluate f of minus 2. So what we do is you have to go and read the domain and see where is minus 2 belong to which domain. So minus 2 is less than 0. So that means minus 2 belongs to the first domain here, because this domain here is x and x value less than 0. So therefore we're using this equation to evaluate f of minus 2. So I put a minus 2 in here, so I have 4. To find f of 0, we do the same thing. As I said, is 0 belong to the first domain? The answer is no, because the first domain says it's any x value less than 0. But the second looks good. The second domain says that x is 0. So we evaluate at x equal to 0. So I mean, this domain he said when x equal to 0, f of x equal to 2. So our answer is 2. Let's look at f of 3. So we'll go back here once again and ask ourselves, is 3, when x equals 3, is 3 belong inside this domain? The answer is no, because 3 is not less than 0, 3 is greater than 0. So that means we have to use the last domain, which is using this equation here to evaluate. So I have now substitute the 3 inside the x. Then plus 2, so we have 5. So that is part A. Part B, that asks us to determine the domain of f. Okay. Remember, this whole thing here is stand for the domain of f. So they ask us to write to determine the domain of f. So the best way to do is to draw the real number line for x, and here is 0. Right. So this domain say that we start out, x is nothing less than 0, we can include 0, so I have open circle, and then x is anything but less than 0. So anything here is describe the first domain. Then a domain is say the next one say that x equal to 0. So that means we include 0. So let's do different color. This means I close the circle. So we have the second part. And then the last one say x is greater than 0. So that means we're going from 0, and greater than 0 is anything from here. So that means overall here, the domain is all real number, from minus infinity to positive infinity. Let's look at C and D. To know the range of f is easy to look at the graph. So let's graph part C and then to answer part D together. So I just copy the problem down, and here is my graph paper to help me to graph the function. So let's graph x squared. This is f x equal to x squared only when x is less than 0. So I'm always using this information here to tell me what to do, because this is actually the domain. So I'm using this is I call the starting point. So I'm using this point here to help me to start the graph. Now this is say our domain is from 0, that's less than then go less than 0, but it cannot include 0. So even though we cannot include 0, I'm using the 0 to help us to start the graph. So when x equal to 0, I put inside here y is 0. So right here, because I cannot include 0, I have open circle. And then this is the graph is the square function. We know that it looks like a V shape like this. Alright? But we're going from where? From 0 and less, or x is less than 0. So what we do is I'm going to pick minus 1. When x equal to minus 1, you put inside here, you have your square. This look like this point. Y is 1. And for 2, I have 4. When x is minus 2, I put minus 2 in here. I get 4. And I continue, pick a few more points like that. Okay, I pick anything that's less than 0. So I know the shape of the square function look like this, and then it will look like that. But we only consider only all the x value that from 0 less than 0. So that means our graph should look like this. It's like a little bit curly, like the x squared graph. And then the next one is say that when x equals to 0, y is 2. This is a point. So when x equals 0, y is 2 is the point right there. And the next one here, I recognize that x plus 2 is a straight line. Right? This remember is f of x equal to x plus 2. So this is a linear function. And once again, I'm using the 0 here as a starting point. Even though our graph won't include 0, but we use anyway to help us to start somewhere. So I'm going to start at 0. I put a 0 here to evaluate the function f. So I have 0. So I have 0 plus 2 equal to 2. 2. So when x equal to 0, not sure, y is 2. So x is 0, y 2 is this point right here. And then we'll pick another point. I'm going to pick 1. So when x equal to 1, I have 1 plus 2 will be 3. Right there. I pick another point. When x equal to 2, you put 2 inside here, I have 4. So you can see that the direction of our graph is go this way. Let me graph, this is green, so you can see it different. Yeah. Like that. So we have a 0.02, which is a closed circle, and you have the green is open circle because I cannot include 2. So to answer part D, they ask for the range. So the range the range. To find the range, we look at the graph here and help us to read the graph and help us to determine what's the range. Right here, a range start at 0. And then we have all the range in the y values will be up this way, and it's go up to infinity. Because the open circle here means we can include 0, and then we can include infinity either. So that's the range. For E, they ask us if the graph is continuous. So continuous, the graph is continuous means it have no hole or no breaking. This graph here is breaking apart, so the answer is no. Now look at example 2. They're asking us to find the domain in the range of f of x. Here's our function. F of x equal to x minus 2. If x is from minus 5 through x between minus 5 and minus 1, we cannot include minus 1, and we can include minus 5. Then f of x equal to 2 times the square root of x plus 1 minus 1 if x greater or equal to minus 1. So to find the domain, I found that it's easy to just, because I know this is mean the domain here. So we can just read it from there and able to find the domain. So I go from minus 5 through minus 1, and here is 0. Okay, so first, this domain here say that x equal or greater than minus 5. So here is minus 5. Equal at minus 5, we can close the circle. And then x is go between minus 1. Cannot equal to minus 1, so it's closed circle. Open circle. Open means not include. Close we include. X between the two. So here x between the two. Then the next domain say that x is equal to minus 1 and greater than minus 1. So this means I'm closing the circle and go greater than minus 1 and go forever is greater than anything is greater than minus 1. So that's go forever. So the domain should be, we go from minus 5 go to the pi is infinity. Okay, so that's how we find the domain the easy way. And to find the range, I found the easiest is to graph the function first and then find the range. So let's graph the function. So I just write the function again and got my graph paper to help with the graph. So once again, this is the domain here. So to graph the first part, I recognize this is a straight line. The slope is minus 1 and the y-intercept is minus 2. Now we only care for the graph that's from minus 5 to minus 1 only. That's the only portion of the graph that we're looking for. So here we start at, so what I'm doing, I'm using this to help me to guide me to graph the line. So this I will call this help me to start the point. I graph start here and a graph will end here. Okay. So I look at minus 5 here. So when x equal to minus 5, I put minus 5 inside here, so I have minus 5, minus 2. So I have a positive 5, minus 2 is 3. So when x equal to minus 5, y is 3. So it's right here. Okay. I know that the y-intercept is -2, because when x equals 0, y is -2, it is a y-intercept. And then we end as x equal to -1. So x equal to -1 right here. Okay. So let's look at what happened when x equal to -1, even though the function does not include -1, but I'm using this -1 here to help us to know where is the end. So we put -1 inside here, so I have -1 and -1. -1 and then minus, so I have minus. Then -2, so I have minus is plus, so I got -1. So when x equals to -1, y is -1 right there. To see the graph go this direction. Now I'm not going to take the y-intercept because it's where x equals to 0, that's not inside our domain, so I have to erase that. Right? So approximately the graph go from here down this way. Now, so I see let's go down and we cross the x-intercept. So the x-intercept is when y equals to 0, so you can just mentally do it in your head. When y equals to 0 here, I get minus x and -2. And when I solve for x, I plus 2 both sides, so I have minus x equal to 2. So therefore, x equal to -2, because I divide both sides by -1 to cancel out the minus here. So x equal to -2. That is the x-intercept. So you like to be very precise. So you go like here, go down this way. Okay. For part 2, for right here, before I move on, I just want to mention that because I cannot go to -1 here, so I just be open cycle here. And right here should be close. Now for the graph part 2, this graph look like the square roots function, and the square roots function from our previous note, it looked like this shape. Okay, and you can just, when we know, generally our graph look like this shape like this. So our graph, we start this here tell me us that our graph start at -1. And because the graph is the x value go equal to -1 and greater than -1, this means it go forever on the right hand side of -1, which is greater than -1. So we have no ending, but at least we know where to start. So when x equal to -1 is right there. So where we start here and see what happens. So to know the y value as -1, I'm going to evaluate f of x equal to -1 using this equation. Now I'm red. So f of x, f of -1, and I have 2 minus 1. Plus 1. And then -1. This whole thing here is 0. The square root of 0 is 0. And 2 times 0 is 0. 0 minus 1 is -1. That means when x equals to -1, y is 0. So we start here and we include a point so we can cycle. We close the cycle. Okay. And then I'm going to pick another point. I'm going to pick 0. That anything that's greater than -1 I'm going to pick because that's our domain. So I have 2 times 0 plus 1. then minus 1. So 0 plus 1 is 1. The square root of 1 is 1. 1 times 2 is 2. 2 minus 1 is 1. So when x equal to 0, y is 1. So right here. Let's pick another point, like let's pick 2. 1 sec. F of 2, so I have 2 times 2 plus 1, then the minus 1. Now I have to use a calculator, so let's see. If I use 2, I will have some decimal number, so let's see. So when I put everything in the calculator, I have 2.46. So I guess I'm going to choose f of x equal to 3, so be nicer. So I have 2 times 3 plus 1 minus 1. So I got 4 here. The square root of 4 is 2. 2 times 2 is 4, and then minus 1 equal to 3. So let's graph the when x equal to 3, y is 3. So right here. When x equal to 2, approximately around here, because it's like almost half, right here. So a graph will go like this shape. Like that. So now we can look at the graph and determine what the range is. The range means the y value. So by looking at the graph here, the range, we start at minus 1, include minus 1, and then this graph here goes continuous, go forever, ever. So we go to infinity, past infinity. So that would be a range.